Hey everybody, welcome to Houdini Hangout on the 4th of January here. Glad to have you with us tonight. Um, Tonight I'm just going to be working through a project that I did to make a little element for the stream here, and I thought it'd be a cool thing to just go through and, um, break down how I made it in Houdini, some of the shading stuff that you're going to have to keep in mind when you're working with Karma, especially with the new XPU version. And yeah, so I think we'll just dive into Houdini and start, doing some work here. So let me pull that up for you. So this is the scene. It's pretty basic. I didn't really do a whole lot as far as building out any elements or whatnot. I knew that I wanted to have, the mug on a table. Kind of wasn't 100% sure where exactly I wanted it to be, whether it'd be in like a standard, kitchen, or if I wanted it out, outside or whatever. I ended up finding an HDRI that was outdoors. And so I went with that. It was like a patio type thing. So I figured that'll work. I'll make it like a, kind of more of a picnic table type thing. And so that was kind of the direction I started going with. And I had actually made this mug for a Houdini competition that Side Effects had run back in March, and so I just reused that. It's pretty straightforward. I can show you the coffee mug real quick before we go too far into anything else. Um, so let's see. I just started with. I'll hide the other stuff here in the background. Started with the tube, polyfilled it just to kind of create these triangular divisions on the top. Used a blast node to just take the top off of it, so I'd have that on the bottom as well. Added a poly extrude to it. Now, there is actually a thicken node in labs. So if you go into, hit tab and go into labs here, actually I can just do thicken. There's a labs version of this, and it'll do something pretty similar. That has controls for just depth and what directions it's going in, basically. So that's a really nice new node that they had added through labs. I'm guessing that'll eventually get pulled into Houdini proper, but for now it's a labs node, and it's nice. So that one works pretty well. I've used it in a couple other things, but this mug I made, I think, before they'd even introduced that. So put a poly extrude down in here, beveled the edges just to give it, just to give it a little bit of, just so you can get that highlight on the corner there. Probably could have done it a little bit less, but it's fine. And then I just did a really simple UV projection on it because I knew that I was going to want to, in my previous scene, I had actually put a little face on it and had it jump off of a counter. In this one, I knew that I wanted to put the Houdini Hangout logo on it, so I made, I kept the UV map the same. And then I just made really simple box for the handle, beveled that, added a bend deformer here. If I hit enter, you can see the nice new handles that they give you for these. So there's there's the bend deformer right there. If we go to this one, we'll see that there's another bend deformer that's up on the top there. And then I just transformed it into place. Now I believe actually for that, I was also rotating it a little bit so that, here, I'm just gonna template that. So yeah, I rotated it a little bit because I knew that I'd want it to be slightly offset. I didn't want it to be perfectly straight, kind of perpendicular to the camera that I was going to put in. So, excuse me one second. This is sliding down on me. I think that'll work better. So I knew that I didn't want this to be perfectly perpendicular to the camera that I was going to put in. So I rotated it just a little bit. Obviously, you could just, as long as you have that in an origin type position, you can adjust that to rotate kind of around like that. So I just adjusted where the handle went, merged them together, used a transform node to put that onto the plane the origin plane. And in fact, I believe that these presets come in if you install QLib, and those are really, really nice as far as ways to, have quick settings in there. If you look under the gear right here, you can see that there's all these different transform things. You can just place it right on the origin plane or on the center. So there's some nice settings in there that I use, from time to time, and this sets that up for you. So yeah, so transform it, add some normals just to make sure it renders properly, and there's your mug. Pretty straightforward, nothing too crazy there. As always, if you have any questions or have anything that you want to bring up during the stream, just feel free to put that into the chat, and I'll try to, we'll try to either stop what we're doing and answer that, or answer that when we get a chance. So yeah. So anyways, that's the coffee mug. I did put some coffee geometry in there. I wasn't sure what direction I was going to see it at, but in the end, I didn't actually use that at all. So it's there, but more so just an extra little thing, not really needed. And then I made the table here. So this is pretty straightforward as well. Just a couple boxes that I copied a few times, just like that. And then I transformed it back to the center here. I just did an expression here to set up my translation so that it would center these duplicates to, so it's centered in this case on the X axis. So I had that set up, and it's just basically taking the count and the offset for each of those duplicates here in here. So the translation and the number, and pretty much just working with that and then dividing it in half to get it to the center. So just a little bit of math in there, nothing too crazy, but and I did that for both of them, I believe. This one also, I had it so that I was using centroid and a bounding box expression so that it would make sure that it's directly on the X and Z plane here, so that when I moved the coffee mug around, since I'd already put that onto the ground, it would actually, I put it on the ground plane, so this way the table comes up to the ground plane but doesn't go past it, so they kind of sit next to each other. So again, these are pretty straightforward, merging it in. Poly beveled everything with a little bit of ignore flat edges with a slight angle there, just so that it would bevel the parts that I wanted it to, and obviously ignore the ones that I didn't. Add some normals, and then I used the auto UV. This is also a labs node, and this does a really nice job of if we switch over to our UV viewport here. It does a really nice job of separating all these pieces out. It's not perfect, but it's really nice and easy to get it done. It's pretty quick to get your UV space laid out. There's some settings in here as far as flattening and packing. You can see I tweaked a couple things here. I changed the resolution of the packing so that it wouldn't try to keep them so far apart, because I knew that I was going to use I think I had 8K textures that I knew I was using. So then that way I didn't go too far with they wouldn't go too far away, and they remain pretty tight since so this only goes down to 4096, but I just left it as is and did 4 packing iterations just to give it a couple options to kind of find the best solution for this. And I really didn't change anything else. It got a pretty good solve, in this UV space as is. So I just kind of left it like that. So yeah, if you're back in these in the perspective viewport and you are in Houdini 19, they've added these a couple things right here, tinting the back facing and showing UV textures, and it's just really nice to be able to have that right in the viewport. You can use a color, a gray, or a UDIM grid. In which case a UDIM grid should have the UDIM number here. And if you don't know what a UDIM is, basically it's a way to pack lots of different textures into or having different UV spaces basically, and having different textures for each of those UV spaces. So there's some, it's a bit of a more complicated way of doing it, but it allows you to kind of pack a lot more textures onto a model and stuff like that. So anyways, that's the table. Pretty simple. I think I just had a box originally and then I added a table. So this was just my box over here. I never deleted it for whatever reason, but there it is. So there's my table, coffee, mug, everything's good. I did actually, now that I think of it, use this coffee here. I blasted out just the surface of it, and I actually used that for my emitter for the coffee. So you'll see that in a second. But so if I come into my sim here and we go up to the top here, you can see my my coffee surface, and this comes in here with a object merge node. Color it red just so I can kind of see it as at a glance. Then I took a pyro source and added that on top of it with fairly fine particle separation. Now this is a small scale sim, so we're at 0.0015, so pretty high on the or pretty fine on the particle separation, but this only gives us what, 2,900 points, so just shy of 3,000 points. And this is, if you haven't seen this newer setup for Pyro, that is something that is used now, is using points to scatter, versus in the past this wasn't part of the process of Pyro. I think probably back, I don't actually remember if it was 18 or something, but it was a few versions ago. They kind of changed around their default way of handling Pyro, and this actually is a really nice new method for sourcing on points instead of on surfaces and things like that. So here we're adjusting the density value, so we're just adding some noise into it. If we look at it here, you can see that that's the noise attributes that are being created. I think red is 0 and blue is probably 0, red is probably 1. If I go in here and edit this, yep, the blue purple is 0, red is 1. So as we kind of go through this, you'll see that change right there, and that can be adjusted by the pulse duration here down in the noise animation. The noise pattern can be changed as well. You can scale it up and down. I think this started up at probably 0.1 or something like that, and you can see how big this noise pattern is to start. So I had to go quite a bit down to get this pattern that felt a little bit more appropriately sized for a coffee mug. So that's the attribute adjust float. This is the volume rasterize attributes. This takes the attributes up here and basically just turns them into VDB volumes. Yep. And takes all these attributes right here and changes them to the voxel size and all that stuff. And basically just spits out 2 VDBs, a density and a temperature. And then we can feed that into a Pyro sim. So that's the one kind of side that's going into our Pyro solver down here. But then likewise, I obviously had to make sure that the mug was coming in here and was going to block the steam as it's kind of coming out. I didn't want it to just kind of go through the edge of that, since it was going to be, let's see if I just add that on there, you can see it's down just a little bit from the edge of the mug. So I didn't want it to come through this, this boundary right here that it shouldn't. So I brought in the mug, actually didn't color that red like I usually do. So I hit C to bring up this palette, colored it red. I also zeroed out the point velocity just to make sure that it wasn't gonna get any additional collision velocities and whatnot in there. And then added in a VDB from Polygon And I'll show you in here that there's different ways to kind of set this up, but this basically gives us an SDF, VDB, and we have a collision and a velocity. Um, and if you look in here in the Pyro Solver, we can see that under collision, there is an SDF and volume velocity under one of the types. You can also do collision geometry, but sometimes I like to just feed it in an SDF just so I know exactly like what the look of that SDF and the quality is, instead of letting Houdini do that kind of on its own. So yeah, so that's that path coming in there. So I'm not going to actually play out this simulation here because it 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 will probably be pretty slow if I'm not mistaken. Yeah, it's pretty slow. So because I upped the resolution on it a pretty decent amount. So I can show you the cache that came out of it afterwards here. And I'll just kind of show you that. And this cache is, is from this labs file cache, which I believe is actually more or less the same as the new file cache setup that they have in Houdini proper without installing Side Effects Labs. So that is a really nice new feature. There's some nice things here, like changing if it's a time dependent cache, whether or not it's a simulation, turning those on or off kind of change the way that the naming structure goes here. And so let's look at this Pyro Solver and see kind of what, I'm on frame 64. Just spam the escape key there for a second just to stop that from going. So let's just look at some of what I've got in here. I've got the voxel size being, driven by the voxel size that I had set up here. I didn't really add a ton of substeps, added a couple just to make sure that as it was coming up, it would get a little bit, it wouldn't be, there wouldn't be any like stuttering in the volume. A lot of times if you have your substeps too low, you can get stuttering in your simulations. And, especially if your simulation is small enough and you have enough buoyancy pushing up your smoke. In this case, I had it started pretty high with the buoyancy, and so those substeps ended up coming in handy just to make sure that there wasn't like the volume wasn't going up and each step going further than it could actually calculate. So that was really helpful just to make sure that, but really there's not much else here. I turned the cache memory way down just so that when I would sim out or when I would cache out the final thing down here, a lot of times what this labs file cache or any file cache will actually try to cache that simulation in the background. And if there's anything on the GPU or anything like that you're doing, you can run into a memory issue. So sometimes it's good to just turn your cache down or turn it off completely when you go to do your final simulation. This is just the cache for this node itself, like the localized cache that you see this little blue bar building down here. So that's why that's down so low. I also set up the maximum size of this object here, or of this simulation. It's probably a little bigger than it needs to be, honestly. I don't know why it's so big, but this could come down quite a bit. It did not end up being that large. So for whatever reason, I might have grabbed that by accident at some point, but yeah, it'll probably sim a little faster now too, in fact. So oftentimes, if you have too large of an initial space for your pyrosim, it'll either take a ton of time to start up, or it'll take a long time, obviously, each frame. So you have to be careful with that. In this case, I'm doing it with a sparse simulation on the CPU, so it's only activating this where there is actually a source defined, and the rest of this is unactivated. So it's really nice from that standpoint. But if you're doing something like a dense simulation on the GPU, which you do here just by pulling this down and then clicking over to OpenCL, that it has to, I believe, if I'm not mistaken, has to load that all onto the GPU to start, doing your calculations and stuff. So that if you have too big of a total volume that the simulation can go into, you can get tons of like OpenCL errors and just go way over on those different, kind of on your memory settings there and stuff like that. So, you'll have OpenCL yelling at you and the console down at the bottom that pops up, and then it'll fall back to the CPU and it'll be super slow. So anyways, that's something you want to be careful of, your initial volume size, depending on what it is you're actually doing there. So, yeah, so sourcing, pretty straightforward. I added a little bit more source density, just because it felt like it was a little too light. I didn't want to have to push it too hard um, in the render and stuff like that, like when I got further down the line. So I made sure that it had a little bit more scale for the density, and everything else is basically the same. This is its standard setup for temperature and for the velocity here as well. So didn't really do anything there. Collision we already talked about. Under fields, I don't think I changed much other than changing the speed on. I like to use that when I'm using the different shaping controls next, and that can be a really helpful thing. If you click on that speed control right there, or that speed field, what that's actually doing is taking your velocity field and writing out the speed, or how the meters per second for each voxel, so that you can use that in your calculation, because you can't use a vector as like a way to control as like a masking type of a thing in the shape. It's a lot easier to use speed because it has a definite range and a 0 to 1 value. So it's just a lot nicer to do. I used to in some of the stuff that I had learned from what is it? Trying to think of the name of it. It's on CG Circuit. They have a guy that does it called Applied Houdini, and he's awesome. He's a TD over at ILM, and he basically showed in one of his lessons on how to change that so that you could actually have that speed control in your DOP network. And I think my guess is because of some of those people that were doing that over time, Side Effects decided to just add that right into their setups. So that's there and is very helpful for changing some of that stuff. This is like a newer UI with these drop downs that they've changed. Not 100% sure why the speed is in this drop down. There's nothing else there, like here color, but it's there it is. So yeah, so the shape is kind of the workhorse of this node. I'll take a drink real quick. So the shape, like I said, is really does all the heavy lifting, I would say, in the Pyro solver node. I mean, for the most part, if you don't tweak this, you're going to get a pretty, not a very refined looking simulation. It's going to be about as vanilla as it comes. This is really where you build up the interest in your simulations. So with buoyancy, that's obviously how the volume is actually going up, how the density is rising based with temperature and things like that. So obviously we need buoyancy in this case because we want this steam to be rising up. But since its scale was so small, I actually turned the buoyancy way down. Just didn't seem like it needed it, and I was kind of fighting with it for a while until I started to get that buoyancy way down. And then once I did, it kind of seemed like it got where I wanted it to be. So that was a big thing to kind of figure out here. If we go down here and look at it just real quick, you can see you can see this raising up, but not too fast. And that's kind of the trick with a small cup of coffee like that, is that it's trying to sim here real quick. Sorry, hit spamming some keys. Why don't I just keep this on, and I will turn off my simulation. I think that'll work. Let me just see here. Can I go back up here? Yeah. Yep, that'll work. So I can keep this on and not, yeah. anyways, um, so that's the buoyancy settings here. There's some other options in here as well. I could probably have adjusted the gravity acceleration as well if I wanted to. That, you could I'm not really sure if there's a huge difference between changing the acceleration and the buoyancy scale. But I just figured that instead of changing how acceleration was happening, how, the quote unquote gravity was happening, I figured just the scale of it would be a way to kind of bring that up or down, and be a little bit more respectful of reality than changing the acceleration of gravity or whatever. So, yeah, so that's buoyancy. There's also a direction in there, which in this case is up. So disturbance is kind of important because you want to try to break up a little bit of the, a lot of when you do just a straight volume calculation without any of these extra like shaping parameters built in here, it kind of wants to make these mushroom cap looking things that don't really look very nice and aren't real at all. And so you kind of have to try to break some of those things up, and disturbance is a really nice way to break some of those things up. Looks like I added about 3/10 in here. The reference scale actually tells you what its size is. I feel like a while ago I would actually put a little cube in there just to kind of see what that scale was looking like. But now you can actually go up here to these shape guides and just click on disturbance, and it'll show you your scale of your, the turbulence kind of that it's creating. It's not truly turbulence, but it's disturbing the velocity at the edge of that kind of cloud / steam / whatever as it's coming up. So it's adding these little points of disturbance in there and not letting it be this smooth kind of smoke barrier that's moving. So in here I use the control field speed, and I don't want it to be adding disturbance outside of this or on things, parts of the volume where the speed is 0. So I made sure to change that just a little bit so that it would not be injecting disturbance into places where the field wasn't moving at all, and then went up to about 0.75. I think the speed of this got to be about 1, so I think I just brought it down a little bit so that anywhere where it was getting close, the closer it got to 1, it would basically be full disturbance. So that's that one. Turbulence is kind of the opposite of disturbance as far as it's not just on one little part of it. It's kind of turbulent throughout the whole, across the whole simulation. So in this case, if you want it to give these little wispy kind of, elements that are coming up from, actually, I'm just going to go down here so you can see it a little bit better. There you go. So for these wispy elements that are kind of coming up from it, you want to use that turbulence field to add those in. So that's where these curls and things like that are coming from. It's not a ton, just a little bit. Also, again, the scale is very small, so the turbulence is kind of fighting against this buoyancy. So I have it just higher than the buoyancy so that it would sometimes go down, but most of the time still go up. If you think about those two numbers, like the 3 can kind of cancel out the 0.03 of the turbulence can cancel out the 0.02 of the buoyancy and add a little bit of down if it needed to. So you have to be a little careful there. I think I was like kind of bouncing around between 0.03 and 0.025. And it's a very small simulation, so there's kind of some really fine control that you have to do there. Swirl size is really similar to the disturbance reference scale, and that is, I set that to 0.15. It's a little bit bigger, so you're getting a little bit more of these bigger swirls through the volume here. And pulse length is just how long it takes for the turbulence to kind of the noise pattern to repeat itself or to kind of evolve through once. And octaves are just how many how many layers of noise there is. You could think of it in that way. So the lower octaves you have, the smoother the noise is, and then the higher it is, the more opportunity you have to make, to help roughen it up. And this roughness parameter here as well will help with that same kind of concept. So they both have similar end results, whereas the octaves is just kind of setting finer and finer levels of noise in there, whereas the roughness is kind of changing the overall smoothness of the whole the whole octave, quote unquote, of noise. So, and this threshold field temperature, that was just their default, and it seemed to be working fine, so I had no reason to tweak it or anything like that, so I just left that as is. And then kind of the last thing that made the biggest difference here was this viscosity field. And I had figured that out previously to this thing. So luckily I knew that ahead of time and didn't have to play around too much with it. But I think I was making some hot chocolate steam that was similar for a project at work. And so that was something that I knew that I had to go in and tweak. I believe for that one, it was quite a bit higher viscosity because we wanted it almost to be like cartoony the way it was going up. But for this one, it's a little bit more almost, more in the realistic kind of standpoint. Whereas, this would actually have little curls and things like that in it, as opposed to being this like kind of fake, streaky thing going up. This would also be something you would use if you were doing, say, like a incense burning or something like that. Something that's just pure, this kind of like trail of smoke going up. The viscosity helps out with that quite a bit. And the best way to think about that is what viscosity does in a smoke simulation or in any fluid simulation is make sure that each of the neighboring voxels or particles in a fluid simulations make sure that they all start kind of moving together in the same direction. And that's what keeps it from getting too chaotic and breaking apart, and kind of keeps the shape a little bit more formed together. So that was why I needed to turn that on, and helped quite a bit with getting this end result looking the way I wanted it to. So the look didn't really matter. That's more for just how this looks in this node itself. I end up tweaking that down there. These are just advanced settings. I don't think I changed anything in here. I don't think there was anything I tweaked in there. And then under export, I just changed a couple simple settings here. I made sure I was exporting VDBs. And instead of using what I think the default is 32-bit float, I just went for 16-bit float. It changes the amount of variations that you can save in your volume, but for this scenario, I knew it wasn't going to need to be anything too crazy. So I just figured I'd use the lower bit rate for the volumes, just so it would save a little bit of disk space. I do have quite a bit on my computer, but it was just, it's kind of a nice thing to save yourself some disk memory. And then you can kind of cull out this volume here, which basically means just take the velocity field and remove anything that doesn't have velocity in it. And I also resampled the velocity volume just because I don't need as much resolution on that when you get down to rendering and things like that. So you can see here the voxel size scale is at 2, so that basically just cuts it in half. And there's a vector VDB just is set to velocity here so that it knows to take this velocity field and turn it into a vector VDB and not try to do 3 floats or whatever. So there's not a vel X, a vel Y, and a vel Z. So yeah, that thing output 3 volumes VDBs, and didn't need to output the CD field because there is no color to it. It's just straight up, white or whatever. So I'll talk about this in 1 second here, but I just went down here basically, used a Pyro Look node, and this just takes the volumes that are coming from this node here, and yeah, if we look here, there's it looks like I've got about 2 million voxels of density. Got quite a bit of temperature, and I'm guessing that's because the temperature is rising up in here. So, and if I come down here, you can see that there's 23 million temperature voxels, about 3.7 million density voxels, and quite a bit less velocity, just because we reduced the resolution of that. So this is the Pyro look node. This is really nice to be able to kind of get volumes written out the way you want it to, and kind of tweak the all these different items in here, fire, scatter, things like that. I didn't have to do any of this here, but it was more so just getting this ready to, just to kind of see what the density looked like. It's really a lot easier to just visualize this in here. I can turn this way up and get a really dense volume. You can see all of these little tiny wisps that kind of go out here that don't end up in the final render. But it's a nice, easy, and quick way to kind of visualize the volume, and it makes it look quite a bit nicer, and you can kind of check and see, how does this look, or, do I need to go back and tweak things? The other thing you can do in this node really easily is change your maximum visualization resolution. And a lot of times by default, your viewport is set to 128. And so it'll look like this when it'll help you with being able to move around your viewport, but it does also kind of make you think, oh, this looks kind of crummy. It doesn't look like I got a lot of voxels here. Instead, then when you bring this way up, you can see that, in fact, I have quite a bit more resolution there than is easily visible with the standard, 128 steps of resolution for that texture. So I actually have turned that off in my own. You can see here the density looks like it's 272 by 352 by 286 right in the middle there. And so if it was at 128, that's effectively half the resolution. So if I hit D here, it brings me into this display options. And if I change the texture, I can turn off this limit resolution. And you really don't want to go too crazy with that, just because that'll totally kill your scene or your graphics card, or it can just run you right out of memory basically. But in my case, I knew I had a little bit of extra video RAM and resolution to handle, so that's why I can see this just off the bat without having to change this visualization resolution. But anyways, so the last part in here that I had to figure out was, since I wanted this to be a looping video, I had to figure out a way to loop my simulation. And obviously doing a looping simulation in and of itself is not something that's easily done, because you'd have to make sure that the state on frame 1 is basically one frame ahead of the state on, in my case, frame 408. So in order to match those up is pretty much nearly impossible. There's no good way to do that. So what I did was I just simmed out this cache once, and you can see here from the start, it just rises up from the beginning here, starts from nothing, starts to do its thing. And so what I ended up doing was using a retime node right here. And this has a lot of great features to it. There used to be like separate, so like if we type in time here and do something like time shift, this is still something I use, but this was kind of one way to set where the frame was. This one has got you can see it has way less options in it than this does. And then you'd also have to use a time blend or a time warp to kind of move these around. You can actually see this drop down to retime node itself. And this is kind of the new feature that has overtaken, but they just have it named in here still as time warp. So that's kind of gone, time warp node. I'm sure you could get to it if you unhit a node, but for right now, that just basically sets this retime into a specific mode. So anyways, this retime node is kind of the newest version in here. And so what I can do is I can take an input frame range, and from each of these, and I can set them to shift to frame 1. And so I did it for two different parts of my simulation. So this retime 2 is the main body of my simulation. So it starts there and it goes all the way through to the end. And then this one here only is going to play at the very beginning, and it'll actually freeze at one point right there. So what I'm doing is I'm taking frame 456 to 480, which I simmed all the way from 1 to 480, and you can see I've trimmed off the end, and I've in these retime nodes trimmed off the beginning and shifted it all forward. And so then all I have to do here is take this range here, this 456 to 480, which should be 24 frames exactly, and this one, which starts at 48, and blend between the two, basically fade between the two. And what that allows me to do is take the last frame of my simulation here, which is 408, and then in this, it's 408, but it actually goes all the way to 455. Then this starts at 456 to 480. So 455 is here at the very end of my timeline, and then 456 fades on, is fully visible at frame 1. And then I I kind of crossfade between those two volumes in this VDB combine node. And so basically all I'm doing here is taking my A multiplier here and B multiplier, animating those against each other. So at the very middle here, they're basically right both at half, and then it switches over to being full B. So then it's fully this main part of my sim. And so I figured a second was probably about enough. I could probably change that to be longer, to have it fade across it on a longer time scale. But in this case, it seemed to be fine. The look was similar enough between those two sections that it didn't really like jump out to me. I did a couple quick test renders just to kind of see what it looked like. But yeah, so this VDB combine node is kind of doing all the heavy lifting for that. It's just combining the A and B pairs, basically meaning whatever volumes are on A and whatever volumes are on B, kind of pair them together and then combine them that way. And the operation I have it going is maximum because basically I want to take the maximum between the two. I don't want to be adding them together because then it's going to get more dense as we get to the middle and they're both on screen, and then get less dense. So I didn't want to do that. There could very well be another option in here that would work fairly well, but I just wanted to make sure that with maximum it would never go beyond that value. So if I did maximum with A and B all the way up at 1, there's not going to be any values that go past 1. But obviously I have it fading, so that helps as well. So I also turned the resample off because they're identical. They're the same sim, so there's no need to resample them. So I just turned that off because that's like an extra little calculation hit that I just didn't want to take. So yeah, so that gets us down to Pyro's look, Pyro solver, and then the out steam set step right there. So that kind of gets us to this look here that we've got going on. And actually a really interesting new feature that they've added in is that you can, when you get these volume selections, you can actually get a much nicer idea of where your volume is ending in just your highlight on your selection. I'm pretty sure that's brand new in 19. It's either new in 19 or 18, but just the fact that you can select it like that is just nice to be able to get a really quick view of like, hey, oh, okay, they can see there's a little bit of stuff up here that's happening. It's not totally obvious, but if I pushed the density a little harder, I could possibly even get some more up there. So the thing that's nice with this look node as well is that, as far as I can tell, it's actually kind of baking some of these parameters into the density and scatter and stuff like that. It's actually kind of outputting that past the node. So it's actually pushing the density up a little bit. So it's a good way to be able to kind of match what's happening in your viewport to what's going to happen in your render. And I end up taking this into Solaris, into Karma, and rendering it in there. And so since it's all a straight, one-to-one within Houdini, it's, Houdini viewport, Houdini render, it plays pretty nicely with that. So that's why I ended up using that node. And if I'm doing explosions and things like that, you can also bake out your emission volume here as CE. And that's really nice because then you can put that into something that isn't Houdini based and doesn't exactly know what to do with a scatter field or a fire field or whatever, but it knows, hey, this is an emission and it's a color. So how do I put, if you set that up in your viewport here and get it looking a certain way, you can port that right into, say, Arnold, which I use often, and we use at our office. And so that's a really nice way to be able to bring your emission right into Arnold, for example, and have it look the same as it does in your viewport. So, anyways, just a last little note there while we're talking about this volume visualization. So you can tell that I did not have this right on the edge of this table. And if you look at, pull up the render here. Let's see. I believe it's in here. Few renders in here. So here's what this looks like. So you can see that it's right on the edge of the table here. And that's not what it looks like in my viewport. And so what I ended up doing was actually taking this into Solaris, the USD context within, or the USD based context is not strictly USD, in Houdini, and did all my rendering and things like that in there. So I'm going to show you that shortly. But first, I actually am going to take a quick coffee break and get myself something to drink here. Been talking for a little while. As usual, if you have anything that you want me to talk about or go over, happy to do that. If you want to throw something into the chat to just kind of start a conversation about something, that would be great. Um, if you're if you're watching this after the fact, you can always come back to another stream and do the same thing. My plan is to be streaming on at 8 o'clock on Tuesdays. If that changes at all, it should show up on my Twitch stream. But for the most part, that's my plan. So what I'm going to do is take a little coffee break here for about, let's say 10 minutes, and I'll be back shortly. Thanks everybody for checking this out so far. All right, everybody. I'm back. Got my Figment mug of coffee here. My wife has graciously let me use her gigantic mug. And so, yeah, ready to continue on after the coffee break. So, excuse me. In order to in order to render using Karma, at least currently, um, the best and really the only way to do that is to add in a go into the Solaris environment basically and render out of Solaris. So let's switch over. The easiest way to do that is just go over here to the stage context, and that's going to switch us over into our stage view, aka our Solaris view. It's going to take a second here, just loading in the geometry and everything. When we go back up to the top here, we've got the entire environment loaded in and everything. So there is exactly the same looking scene, but now we are working in a in a USD context within Houdini, and that's what they call Solaris, and it's really really nice as far as a really nice way to be able to understand the concepts of what specifically USD kind of bring to the table and how that can work. Now, Solaris has a lot of things built into it that USD by itself doesn't, but it does encapsulate the entirety of the USD kind of world and how that works currently. So, yeah, so what I have right now is a pretty simple scene, but in order for us to see this a little bit better, we really need to change our panel so that we can read out some other information. So I'm going to change this over to the Solaris look, and this should give us a bit better idea of what's happening here. It's more or less the same, but it does open up this scene graph tree down here, which is really helpful to be able to kind of understand what's going on. So, some of the nicer, they've added a couple nice nodes here, scene import nodes. So what they do is they just basically, if you go to scene import, you can see here that there's materials, lights, cameras, or all. This, I believe I used scene import all because I was originally looking to bring it all in by itself or all in one node. But then I decided after the fact to split off the Steam into its own node here, which you can see if I switch over, there's the Steam. So and that was mainly just to be able to, for speed's sake, just be able to kind of go, I don't have to, in order to kind of see the way that, for example, the camera was moving. With this, we're probably moving here. If I go up to the display options, I'm just going to turn these things on so we can see. And if we hit play here, yeah, it's going at about a frame a second. So it's definitely chugging along. So if we turn off the scene import all node with the Steam on it and just play back, now we get a nice solid 24 frames a second. So just kind of a nice way to be able to, I just basically took it and soloed those elements out. So let's look at this node first. And what I'm doing here is I'm taking in everything that's within the root object OBJ, so just our object space, and bringing it into the stage under this geo primitive. And this is a way to basically group things together. So I know that all my geo is going to be under this this hierarchy. So you can see here I have my geo coffee mug, table. So and those are the nodes that I had written out previously. The only thing I changed in here was I excluded the Steam from this, and I think that's it. Oh, I think I also brought in these attributes here. I also turned off the materials because I knew that I was going to build the materials in Solaris, and so I didn't want to be like doubling up and having maybe another material on there that I don't end up wanting to use that's already assigned to these. So I basically just said no, don't have the materials come in. And I'm pretty sure I turned on these attributes just to make sure that any UVs or anything like that, that they would come through. I'm pretty sure they would have without that, but I just was like, well, I'll just make sure the attributes are coming in so I don't have to play with that down the line. So then if we look at this scene import node here, this brings in the Steam itself, and that basically only puts it under Geo Sim Steam. And so when I go down to this merge node, you can see that that merges in that Sim Steam right here. And if I turn this on or off, it's just going to change that element there. I did try to turn off the activation here to see if that would kind of win me back those performance gains, but it actually didn't. I was kind of surprised by that. I don't know if that's intentional or why exactly that's happening, but yeah, so if anybody has a good reason why that's happening, you can always drop that in the comments below. But yeah, so for that's kind of just merges in all of our geometry and everything. And then I wanted to actually go through and edit where these things were. So I use this edit node here, and that really gets brought up just from selecting something in the viewport. So if I was to select, say, this table here and hit T to transform it and started moving it around, this node would have been created when I started doing that. So basically what this is doing here is showing, I guess, what different elements you've done in here. So it's showing that I've done transformation. I've changed the transformation attributes of the Steam, the coffee mug, and the table, and I've changed the rotation of the table as well. If I would change scale or whatever, we would see that as well. So here I can turn those on and off. This is just like the bypass flag that are on nodes in Houdini. So you can see this bypass right here. This is actually the first time I've even noticed this. I just noticed it as I was kind of walking through this, was that if you turn this on and off, you can actually turn off the parameters that you've changed in this edit node. This, I mean, if you're watching this, you probably already know this, but this is the beauty of Houdini, is that you can actually do this stuff and not break anything else. I mean, I could literally turn off the movement of this table here and then just go down and render and it'd be fine. Like nothing is really going to break in this scenario because all I'm changing is position and rotation parameters. So I know that everything else is going to stay mostly the same. So for the most part, that's the case there. So that is the way that I moved it over. I also added a camera out down here, and you can see that's the camera view that I've got right there, which is the video that you saw during the break. And this is obviously the exact angle of that. But I actually I had this view set up first, and then I was like, oh, I should probably add some text here just to kind of explain what's going on, have something in the view other than just a coffee cup. So then I went back up and went to this SOP create node. And basically what this does is just creates a geometry context that we can jump into. And you can see right here that this is now a SOP net and we're in a geometry context. And this is exactly like regular nodes would be in standard Houdini. So just got a font node, divided it just so that I would make sure that I'd have like decent polygons on the faces so that when I extruded it, it wouldn't freak anything out. And I just fused it to make sure everything was playing nice and there weren't any like weird breaks or anything like that. And then I beveled the edge a little bit right there. I'm pretty sure I turned on ignore flat edges, and I believe this stop loop simultaneously was helpful to be able to make sure that some of these corners didn't get like over beveled and like start to like go into each other. So yeah, and then I added a normal just to make sure that it had normals on it and stuff like that. So that created my coffee break text where I needed it. But then when I came into my view here, I kind of wanted to adjust it a little bit to make sure it was in the right spot, because it was sort of hard in here to exactly see where things were being made, especially if you have it like this and you're just working straight in here. If you have your ghosted objects on, you can see a little bit better. So I might have been able to tweak that just slightly, in hindsight. But basically what I did is I created this and then went up and saw, I need to tweak it just a little bit. So wanted to bring it forward just a little bit. So I used an edit here, basically just changed the transformation of it a little bit, moved it forward, and that was that. So in this here, you can see, where the camera is. And in fact, I'm now noticing that this is actually the focal point of this camera. I'm noticing how far forward of that text is. So actually probably should just take this text and move it back a little bit to match it to, excuse me, to this. So I'm just going to move it back a little bit. Yeah, that's pretty good. I could probably move it forward just a little. Let's see where that puts me. Yeah, well, probably, I don't know. Maybe I'll re-render that. But so that should be a little bit sharper now, in fact. But anyways, that's the that was the camera that I had added into here. And then what I did was I actually had to translate. I wanted to kind of have this like floating motion to it so that it wasn't perfectly still. And what I did there is you can right click on this and just add in a motion effects and add in some noise right here. And so then that adds this motion effects chop network down. You go inside of here and you've got your noise. This is your camera clip. This is what's actually coming in from the camera. And then this is the noise that it's kind of adding in there. And so then this is the sparse noise. And then this math adds it together. And because it has this on here, it's set to export. So this will export back to those parameters. So basically it's just a way to take some information in from the scene here, which is the camera 1 position, and then bring that in and add some noise into it basically. And so then when you look at this node here, you can see these little boxes here basically means that that's got something that's coming from this chop network that's overwriting it basically. So I'll turn off my Steam here, and you can see that as long as I'm in this camera here, you can see that this is now kind of just moving around a little bit. And the one thing that I did that was really helpful in there was I took my noise and I went into this constraints tab right here and made sure the start and end value was 0 for the noise. And basically that just makes it so that it gets back to the same point at the beginning and end of that loop. So there's no jump in the camera position. So that was the camera setup right there. And then I added in a dome light. That's where my HDRI came in, the kind of outside HDRI. And so Solaris is pretty nice as far as this goes for, that's not what I meant to do. I'm going to take this down just a little bit. Don't need so much room taken up there. So Solaris is really nice for having this, viewport that's showing you a lot of stuff that's happening in it, and everything's kind of reacting to it. Now, right now it's using just a standard, OpenGL Houdini viewport, but you could change this at any time and start to get, feedback from it. So what we have here is, this is just a dome light. It's got the texture in there. Not really much changed, I don't think. Probably up the exposure a little bit just to make sure it looked right. And then I added in a area light. And with that, I actually made sure that if you select the specular up here, you can actually get a little, if you click on geometry, it's actually going to show you what angle and where that's kind of like allows you to place your specular highlights in your scene. So there's also some stuff up here where you can keep the orientation, keep the brightness, things like that. And that allows you to really control where highlights are hitting, where your diffuse light is hitting. You can set up shadows to be where you want them, all that kind of stuff. And it's really, really helpful. You can also just set the width and height of your lights right here. So, so that's pretty helpful. The next thing I set up was my materials. And just as a quick aside, this chain right here that I've got going, you could set this several different ways. I could have it, these, like the camera and the lights merged in if I wanted to with a merge node. I could have them change the order. It doesn't really matter in here as long as when you get to the bottom, it's doing the things you want it to, you'll be set. Obviously, it goes from top to bottom, just like regular Houdini nodes would go. But yeah, so I could switch this camera to the bottom down here, and it would be the same. The only thing that's kind of nice, as far as setting things up, like, yeah, maybe I'd want to put this camera down here because now I actually have my lights in my scene and I can view through this camera. So, it's kind of a, you know, wherever at whatever part of this of the scene you want your camera to be at, you have to have that written in your chain already. So that's something you kind of need to think about too. I mean, like, I just had the camera in there and then I think I added the lights, and sometimes that's going to work. Sometimes you need to make sure that you're doing it in a different order. So just something to think about. Oh, that area light I had changed too, just as I changed a little bit there, rectangle and some of those properties, but not a ton. Anyways, material library, that was the next thing that I got into, and really it wasn't too much stuff that I had to do. The text is literally just a simple color here. What I'm using for this is a subnetwork that if you go into here and go to your Material X, there is a Material X subnet. And when you do this and you open this up, you're really only going to get things that work with Material X, which is really nice. In fact, what you could do as well, I'm not sure actually which material network I was using. Let me just look here. Yeah, I think that's the normal one. Okay, this for whatever reason I went back and forth with it, but there is actually, if you do, let's see here, where is it? Yeah, here it is. So if I do this Karma Material X subnet, it will have Material X and also things that work with Karma as well, and Material X. So there's a few more things in here like Karma hair and some things like that. So just a different way to do the subnet. But what this does is basically takes it from this gigantic list of things that don't all work actually in standard, Material X/Karma, and kind of pairs it down to stuff that only works with Material X or Material X and some of the Karma things. So, excuse me one second. Take a quick sip there. Material X is really great because it's an open source material framework, shader framework that allows you to transfer shaders between different render engines. So like if I exported Material X out of here, I could bring it into Arnold, and Arnold would read in Material X and then set up the nodes that it would have that match what I'm using in here. So there's all sorts of different ways that you can kind of use Material X to move between different programs or between different render engines, things like that. So super, super helpful. And it's becoming integrated into Solaris, so that for the simple fact of any thing that's in here, any Hydra delegate, they call them, which is the render engines, can read it. So it's super, super helpful. And it's something that they were mentioning in one of their recent, I think it was in their recent, probably, I don't know what it was, if it was a Houdini Hive or what it was, but they had some learning materials that I was watching, and they were basically saying, why would you make it in Material X? Why would you do it in standard? Like their standard older style was the principled shader. So you could just drop one of these down and this would work as well in Karma. But they're saying basically they want to start moving towards Material X just for the fact that all major renderers are starting to support that. And the more that they can integrate, the better that cross kind of platform will work. And just changing your renderer up here will actually read all the same things in, no matter what renderer you're using. So that could be obviously really just, it's obvious that would be really helpful. So that's why I chose to do Material X. In here you can see that there's a Material X surface kind of collector node, but what I did instead of doing that was I just did, if I just type standard in here, this is their like kind of default standard shader. So instead of keeping this here, I just dropped this into the subnet output right there and just got rid of this. That doesn't really matter. So this is outputting the same thing, and it's their standard surface shader. I can collapse that if I want to. And this is what the text looks like. You can see that there's a Material X standard surface, which has all these different things, you know, base, specular, transmission. I think they said subsurface isn't working yet, but they're going to get there, and a bunch of other stuff. But I didn't need subsurface, or at least I just decided I didn't want to use it. So, yeah, so that one doesn't matter. But this is the text network here. You can see there's the standard surface. I just changed the color to orange just to match some of the stream colors and things like that. I don't even know if I tweaked anything else. I think that was literally it. I was just like, just make a base material for it. Didn't need to be anything fancy. So then I go up here to the mug, and you can see some of the things that are happening here. Just reading in the primitives basically to make sure that my and doing a slight transformation on my image. So basically, I'm taking my USD primitives here from, which I believe is, instead of UV, is ST. Not 100% sure what that's all about. If there's something there I'm missing, but I'm sure it's just making it so that you can have a different attribute without like writing over your UVs, because it's in a different world basically. So a little bit strange, ST, but anyways, yeah, so then this just changes the translation of that, and sets that so that it drives the icon that I had loaded in here. Actually, if I go down to here, we can see those. Now, this is actually what's coming up in the viewport. I believe that's because there is actually under the hood, there is this auto generate preview surface shaders. If I turn that off, so this is automatically creating a preview surface shader. So it's actually creating shaders that aren't 100% correct, unfortunately, but it's not really a huge deal in this case. I don't need to see it perfectly one-to-one. If I wanted to, if this was for someone else and wanted to make sure that they could see it in their viewport perfectly, I would set up a preview shader in here as well in my material library. But it wasn't something I needed to do for just myself. So that, the mug here, the other thing I did was just did a black and white version of the logo and remapped it so that it would adjust the roughness, the coat roughness, so that it would kind of feel like the logo was more on the outside of it than, on the inside. So basically I'd put a base I just have a base value here with a little bit of roughness on it, and then I have a coat on here as well with roughness driven by that. So it's very low roughness, just to kind of give it that little bit of extra, shine and also a little bit of depth maybe to it, just to feel like there's some more going on there. I also deleted the displacement just because there wasn't any in here, and I didn't want it to be thinking, oh, no, I didn't. I thought I did. It's just down lower. I think I did in other ones. Maybe not. Anyways, so that's the mug shader. Nothing too crazy there. This is an XPU Pyro preview node. This is the only way that you can get Pyro to work, or volumes to work in the XPU, which is the CPU and GPU renderer together. It's the only way that it'll actually do that right now. I believe there's a way they're probably going to try to create something similar to like Material X, where everything is built into one node that works for both. But for now, Pyro preview, there it is. XPU is the current, like I said, CPU and GPU combined renderer, and it's fast. And so that's why I like to use it, because it uses most of my computer resources, and that makes me happy and is pretty quick. So this is pretty straightforward. I don't think there's anything I really needed to do in here. I don't have anything up other than, I literally didn't change a single thing in here because I built that Steam to have the density I wanted it to in the viewport. So it already is pretty much right there. Like, that's what I want it to look like. So, um, yeah, so that's pretty much how I want to have it. So what I'm going to do real quick is start to show this, the way that this works here in Karma itself. So I'm just going to come down here, and I'm actually going to set this to the CPU engine just for now. Maybe turn this down. So turning the samples down, that's going to turn the quality down. There'll be more noise, but it'll start up a little quicker. Hopefully this isn't going to kill my stream too much. Just keep an eye on this, make sure it doesn't start dropping frames like a crazy person. So right now it's just loading all of those things into memory, getting it kind of built up and ready to go. Um, there we go. Now it's rendering. So this is the CPU renderer. There are definitely some weird little things here going on. Looks like Material X might be having an issue there. Down, if you look down at the bottom of the cup here, it looks like there's actually probably some sort of Material X issue that's going on there. Not 100% sure what that's all about, but yeah, you can see how noisy this is right now. It's really struggling. Karma is nice from the standpoint of it's pretty robust, but it's definitely not super fast. So I think that was one thing that they probably felt pretty hard and were like, oh yeah, we probably want to fix that. But anyways, as you can see here, as I move around in the scene, it updates pretty quick, starts to resolve pretty fast. But it certainly isn't the fastest renderer in the world. And yeah, it takes a little bit of time. You can see up here, you've got a countdown. So it might take a minute and a half to render, maybe a minute to render a frame, which certainly isn't fantastic. But this is kind of why I like to use the, I'll go back to the camera. This is why I like to use the XPU. So I'm just going to set it back to Houdini GL. And this preview, this Karma node down here is actually driving my rendering. And you can set that through render settings right here. You can see render/render settings is what's the default. You could also change it to viewport settings. And then anything in this, if you hit D and go to render, this will bring up the render settings right here. So I can actually have separate, it's kind of wild. You can have separate viewport render settings, and then you can actually have final node render settings. So it's kind of nice. You can have this set up pretty differently. And this shows you can show options for any of the Hydra delegates. Like if I had Arnold installed on here, it would show up in there. Redshift would show up in there, etc. So if you had Render Man, it would show up in there. Not sure what else they support right now. I'm trying to think if maybe V-Ray. I'm not sure about that one. But anyways, this is all the same kind of stuff as here. It's just a little bit more simplified. But yeah, anyway, so set that back to that. And so what I'm going to use instead is set it to this, because you can see right here, render/render settings is actually a primitive that it writes. So it actually writes this render primitive and sets all these different things in here. So like, I wanted to make sure that I had normal and beauty and albedo on, because that's some of the stuff it uses for denoising, for example. So I turn those image outputs, the AOVs on. I'm just going to slide this down. So those are set up in here. Here's my, these are like limits, like sampling limits or ray limits. Actually, it's probably like ray depth, because these are samples. So yeah, there's a lot in here. I haven't played with all these different things yet, to be completely honest, but yeah, so there's probably ways to speed up the CPU engine too. But if I go over to the XPU engine, kind of changes things a little bit. It changes this sampling, and that's actually makes sense as to why I wasn't seeing these ray samples and things like that, because I was over in the XPU engine. There's not going to be quite as much. In fact, there's not even a subsurface in here. There was with CPU, but also the sampling is way less here. So let me just turn this on, and I'll let you take a look at how this works. So if I turn on Karma here, the gear is gonna spin for a second. And this is an alpha, that, as it says right here. Definitely not ready for this to be like a full, um, used in productions or anything like that. But it is super fast. And what you're seeing here, you might be thinking, well, this doesn't seem super fast. But, and there it goes. Just kick on. First, for whatever reason, the optics, it takes a second for the optics rendering to turn on. So in this case, that's your GPU, right? And you can see right here the percentage this actually shows the split between the two. So if I come up here and hit restart, this should kick optics on right from the start, because it started up once. It's loaded everything into the GPU memory, which takes a little bit longer. If you've used any GPU renderer, you know that usually it takes a little longer to start that up. Redshifts pretty quick, but anyway, so now you can see optics versus CPU. Optics is using a ton of it, and this is at 120 samples and 16 seconds to render. If I turn this up to the 512 we had before, and I go, it looks like it's saying it's going to take a 30 seconds. And so this is about half to a third of the speed that it was seeing the preview render. And that can change a lot depending on what it is you're doing, but suffice it to say it's a pretty nice speed. I'll just turn this off. You can turn these light kind of little icons in here on or off, and that way you can see a little easier. Anyway, so this is going through. You can see all the statistics over here. I was not just for my own kicks or whatever, but you can see that about 80% of the rendering was done on the GPU in this case. And I have a Threadripper CPU in here, so it's a pretty decent computer for rendering and stuff like that. But the GPU is really great at rendering, and it's pretty obvious in this case. So I turned the pixel samples up to 512 because I really wanted to get a nice, I wanted to not totally smooth everything out, which happens a lot with denoising, but I wanted to get it to a pretty nice spot. So I turned it up to 512. But if I set this to 128, for example, excuse me, you can hear any of the sipping noises there. So that rendered in 9 seconds, right? That's pretty quick. There's certainly going to be a lot more noise. It's probably hard to see in the stream, but there's a lot of noise in this cup here. There's some more noise in some of these edges and stuff here. But what we can actually do, and we can go into the image output filters, and we can either use optics denoiser here. It's mad at me because I think I'm not sure what it is. It might be because I had Arnold installed previously, and that has an optics denoiser in it. I'm not 100% sure, but anyways, this is definitely going to smooth this out way more. I mean, there's basically no noise in here. And if we did the Intel open denoiser on this is again going to be practically no noise. It's going to be super smooth, and there's going to be basically, yeah. I mean, it's the Intel denoiser is awesome. It's really great. It gives, as long as you give it a decent amount of samples, it really doesn't show much flickering, as opposed to, I feel like optics tends to have more flickering in it, when they don't really recommend a lot of times to use it for animation, but the Intel denoiser is great. It's in Houdini now as well. I think they're trying to add it to Redshift. Great denoiser. So, you could set it to be, let's see, what if I did like, I don't know, 24 samples. I mean, the difference between that and going up to 128 is barely any difference when the denoiser hits. So when the side effects was running their Mardini, their competition, basically, I would kill to have this, because that I had to do I did it all through Arnold because I knew it, and I knew I could set up Arnold really fast, but Arnold is nowhere near as fast as this is. And for just trying to get a quick render out, um, this is, I mean, it's insane. There's no noise in that super out of focus background, and the volume has basically no noise in it either. And this took less than 10 seconds. So, anyways, Karma XPU, huge props on it. There's lots of stuff you can do in it already. And one thing I actually noticed here while I was looking at this was that my volume was set to 0. I'm kind of curious what's going to happen if I set this to 1. Interested here, see what happens. Maybe I'll say maybe wonder. That would be an interesting thing. Hmm. What I'm going to do, I'm gonna actually take some snapshots here. Just gonna bring this down. This little bar right here is your snapshot bar. And the really interesting thing here is that I'm going to turn off these render things just in case it, I think it's that, yeah. Just in case it snapshots that. I don't know if it will or not. I haven't done this really that often yet. Okay, so what this will do is this is actually going to snapshot what I had done here in this frame. And if I change this to 0, let it run again, I'm going to snapshot the same thing. Now, the really interesting thing about Solaris is that the snapshot will actually save your network as well, like the changes that you make in your network. So if you look down here and stuff, change one thing, you snapshot, and you can go back into another thing, you can actually switch back in your network in that as well, which is just, I don't know, it's ridiculously cool. I don't know how they do it. It feels like absolute black magic, but like if we say revert network to this snapshot, if you right click here, you could do that. It's just it's insane. So like if I hit this, it's gonna make sure that this node is set to 1, and if I reset it back to this, it's crazy to me. But anyways, sure what that didn't change anything. It feels like it should have, but oh, you know what? Let me just do this. Let me view this image. Okay, let me see. Maybe I will actually see a difference here if I go between these two. Okay, yeah. Yeah, there definitely is a difference. You can say it adds 1 second to render, but I might re-render that then and maybe you can get a little bit nicer quality out of that. But I also changed where this was sitting, so might actually be a little bit better in focus anyways. So yeah, maybe I'll be doing that and re-rendering that. But that's under this little snapshot strip here. So yeah, so that's more or less the Karma render node here. There is also, if we go to labs Karma, no, I don't remember the difference here, and you can kind of just tell from the look of it right here. The difference between these two is that this one is, this obviously just your standard Karma node. This is the labs one, and this is going to kind of be familiar to anybody that might have used PDG slash Tops, the Tops network. And this is, I think, what they want their render nodes to look a little bit more like, and a lot of their elements, because what this is actually adding in is this top net inside here. So you can actually, go inside of this and see what's happening here. There's a standard Karma node in here, but this is doing so many things on top of it that it's kind of cool. And actually what you could do is you could render this to disk in the background, and it'll keep, it'll have all of your frames show up as little tasks down here as little items, and it's going to group each of those individually in the background. You could just keep getting if you wanted to, and obviously that's going to eat down your performance, but you'd certainly do something in here if you needed to, even if it was just setting something up for another render or whatnot. But yeah, so the this is the labs karma, and you can also see that there's wedging built in here, which basically just means you could have separate, different parameters and things like that, different attributes that would change each render as it goes through. So you could have multiple renders that it would run through at the same time. And like in this case, I could have set, that volume, the how many samples it's doing through the volume as you go, and that would you'd allow you to do that without having to set up multiple renders to go. You just add a couple wedges in, tell it what attribute you're changing, and then it would go from there. Um, the other thing that's really cool is they have started to build in these versioning right here. So what this will actually do, you can read out right here. This is my the file path to that, and it would be, it uses this node right here. So if I called this something like final render, it's going to change that in here. It's going to put it into the folder that I was working in. It's going to put it into my render folder, then say final render v1, and then final render v1 blah 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 .exr. Can also go in here, change if it's an exr, png, tiff, jpeg, all that stuff. That's going to change. Not sure what the clean version is. That's interesting. I have to look that up. These are all interesting too. You can literally open the directory. Um, you know, this is going to open the file chooser and stuff like that. But you can do all sorts of different things in here. Yeah, you can see right here. There's different hip folders I could put it into. The base name I could change from being OS, which is the name of this node, to whatever. And here you could change it to from constructed to explicit, and you could just write it out there. Here it's constructed. A lot of the same stuff is gonna happen in here. The scheduling is actually how it's setting these frames that are gonna come up into this behind the scenes top network. So that's some of that's when you see scheduling. That's tops. That's PDG that's working. Here's the karma stuff. All the same type of thing here that you see on this part of the node. But let's see if I turn it to this XPU, some of these things are going to go away as well. So all standard stuff here. Resolution, turning on and off depth of field or velocity blurs, telling it to denoise or not denoise. Right there. Different shading stuff, geometry, turn on and off caustics. Here's all of your AOVs you can turn on and off. And then this again is all the advanced stuff, which is kind of insane. But these, I believe what they did here is they kind of broke all this stuff out to allow them to have control of the stuff that's going on inside of there. This is just a kind of smart way to set up an interface within Houdini. And if you've never done that before, you can get into the gear up here and edit the parameter interface, and then you can actually see all the parameters that are in your node properties and things like that. So anyway, so this is there's a ton of different stuff in here that you could get into. The tiles for your rendering. If you're doing EXR, there's settings in here for it. Just a ton of different stuff. And so this node is actually really, really nice from that standpoint. And you can see right here, it's going to set the primitive, the settings onto the render settings, the same that it's doing for Karma here. So that's a different way that you can go about doing that. You can see this up here as well. I don't think, that doesn't show up for this node. Yeah, no, it doesn't show up for that node. This is again a new thing that they're starting to show in here. Different kind of tool tips that are up on screen here. It's just, Houdini just never stops amazing me with the things that they add in their releases and things like that. If you can't tell, I like Houdini a lot. But anyways, so that more or less is, top to bottom this project. And hopefully this is something that is helpful for you to kind of see how, a relatively simple project like this in Houdini would be set up. some of the stuff in Solaris, which is really, really nice. And just how to kind of get this nice, super fast render out of something like Karma XPU. And yeah, so I guess the last thing I can just kind of touch on is this other node that's just kind of floating over here. Just today, NVIDIA released their Omniverse software workspace. I don't know what to call it. It's kind of like a mix between. It's like a mix between a regular DCC and like almost like Unreal Engine in a way. It's super interesting, and so what I decided to do is just write out the USD file to disk that I had made here, because this is all USD. This is all based around USD and can be written out as USD. So basically, I just put down this USD ROP, put down a file name where I wanted it, made sure it was saving in the right spot, and hit save to disk. And oh, actually, that's interesting. I only did render current frame, which is fine. It doesn't really matter. I was just trying to test it. But what USD allows you to do, and as long as a USD program would support, Material X in this case, or whatever different, thing that you're putting through your network in Solaris here, I was almost able, without a huge amount of work, to just take this whole scene, bring it right into their like new real-time Omniverse world, and just load it in there and start rendering and kind of playing around with it. So was just something I kind of wanted to try, and is the one real benefit about this entire Solaris kind of workspace, is that you can talk to other programs through USD really easily. There's some really neat stuff, especially if you're interested in if you're doing a lot of Houdini work. There's a lot of really cool stuff in their most recent kind of workshop that they released on their site. I think it was like in November. It's probably like when the release of Houdini came out, actually. And they break down some really cool stuff, simple ways to think about setting up USD, which sounds insane to say simple and USD in the same statement, but just some really nice stuff in there. And so I've been trying to embrace Solaris a little bit more, especially with like when it's just me rendering for myself and I don't have to be at work and working with a team. Again, like I said, at my office, we use Arnold for a lot of rendering, and also Redshift a bit. And so when we don't have to do either of those and it's just me, I do like to kind of keep, work in Solaris and get some, just get some time in here to be able to kind of hone my skills on it. And it's fast, so I'm not going to be angry about that at all. So, well, I was originally thinking that maybe I would get through this a little faster and would work a little bit on my Formula One project tonight, but it's looking like I'm getting close to 2 hours here, and I don't want to make these streams too long. And unless anybody has anything that they wanted to add in the chat, or through anything like that, I think I'm probably going to start wrapping it up here. So, like I said before, this is a stream that I'm going to be trying to do, once a week. Usually on Tuesdays. Sometimes I might just hop on if I'm working on something and just stream it, just so people can see what I'm working on, and if they want to come hang out, they can. Tried that last night, but had some internet issues. So tonight it seems fine. So I lowered the bitrate slightly, and I think that solved the problem. But yeah, so my name's Peter. If you're interested in following me on Twitter, it's Peter Cubic is my handle. And so follow Houdini Hangout online if you'd like to know when we're going live. On Twitter is the best place to do that. I'll usually send out a tweet when I'm going live. But otherwise, thanks for watching this, for joining me if you're watching live. Just if you happen upon this after the fact, just keep an eye out for when the stream is going live next. And hopefully you enjoyed the information here. Thanks so much, everybody, and I'll see you next time. Thanks.